Okay, so the original model didn't work very well, so what we need to do is edit it to change it so that first it's going to run for longer, and second I'm going to change the population model to a fixed population. So I need to open it with Beauty, the existing file. Now file, load, Korean.xml. And now I need to just change my priors, so I'm going to have coalescent constant population, and I'm going to change the MC to be, I'm going to make it 10 times larger, which means I also want to make the logs for the trace logs less often, 10 times less, the screen logs 10 times less, and the trees 10 times less, unless I want to end up with an awful lot to deal with. File, save as, and I want to save this as Korean 2 because this is the second model. The other one will be Korean 1, and then I can exit. No, don't save before closing, we've got it already. And then I can go to Beast, choose the file. I need to go back to my GISAID files and open Korean 2. Everything else looks fine. Press run. So again, I need to go back to Tracer and see if this one's performed better. So first I run it for longer, and second I've also changed the model so that it's on the constant population. So if I click on Tracer, run on Tracer, exe, file, import to the trace file. Not in documents, it's in downloads. Downloads. Oh, no, not that. Downloads. Downloads. And it was in GISAID. And it's the Korean 2 log because it's my second model. Fantastic. That's what I like to see. So this worked. If I make this a little bit wider, actually it doesn't make any particular difference. So you can see from the sampling in this ESS column, all of them are now in black, none of them are highlighted in red or yellow as being undersampled. The model has been well fitted, it's got a constant population size of 332. If I have a little look at the spread of them, they're quite reasonably set up. I've got a good clock rate, I've got good convergence on my gamma shapes. Everything from this is good. That is a well formed model. So now I can go back and I can build the trees. First I can I can go through the tree building process for this second data set. So the first thing I need to do is do tree annotator. I can burn in percentage of 10%. Maximum credibility tree. I like median heights. Need to choose the tree file. Again, it's in downloads, GISAID files, and it's the Korean 2 trees. And I'm going to make the output file be called the Korean 2 model, not tree. And click on low memory because otherwise it doesn't work properly. It's processing 9,000 trees after ignoring the first 10%, which is 1,000 trees, finding the maximum credibility tree, and then the medians for each of the values. Now, while this is going to be a better tree in terms of sampling, I don't really expect it to be any different to the tree that I got originally when the sampling wasn't very good. I expect most of the sequences to be in exactly the same order as they were before. There might be some small changes, but I don't think so. So that's done the tree annotator step. Now I can go to Fig Tree and view the tree. So run Fig Tree, file and open. It is the Korean Model 2 tree, which I can't find here. I get this horrible feeling that it's put it in a different place. I knew when I was doing the thing. Where has it put it? Models. Nope. Let's put it in Beast 2. Korean Model 2 tree. Yeah, it has. Fantastic. Let's move it to downloads and move it from downloads into JSON files. Fantastic. Now I can open it. File, open, Korean 2 model tree, open. Now I want to do a bit of expansion so I can see it properly and read all those bits of text. I prefer to make it a bit wider so I can see what's going on, and I'd prefer to align all of the tips so they can see the lengths of the different parts of the tree. Got that scale bar, which I don't like. I prefer to have a scale axis, and I want it to have a reverse axis, so 0, which is the most recent sequence, is there, and then it's minus how many days going backwards. I want to have node bars which describe the height, the 95% HPD. So that's a kind of confidence interval. It's the posterior distribution is its technical name, but it's like a confidence interval. So it is an unbiased estimate of the age, the height of that particular tree. So this is minus 1,250 days. So it could go back, and each of these marks is 1, 2, 3, 4, 5. So each of those is 50. So it could be, that would be 1,300, 350, 1,400. Could be 1,400 days before the last sequence in the outbreak that change happened. So actually 1,000 days before the start of the outbreak, that the split happened between the 2.3.4.4b and the 2.3.4.4c lineages happened. There's some interesting long ones here where you've suddenly got some dramatic changes. Another one here where you've got a dramatic change. Here you've got some dramatic changes, and then there's a little cluster. So here these ones are all from Korea, and in ducks. Well, no, these are ducks, these are geese. So it doesn't look like that cluster is dependent on species. And then there's this other cluster here that continued. So there seems to be a strange set of subpopulations. Now, the next thing that would be interesting to look at is to take the sequence of this one, the sequence of this one, the sequences within that group, and the sequences within this group, and find out what are the nucleotide changes which define the different groups. So to do this study, the only thing you really need to do is do the alignment, the trees, and then possibly some subsequent alignment to try and understand what the differences are. You could stick with the original alignment, which has all 360, and just find the ones that you need within it, but that's probably going to be harder than getting the sequences and doing an alignment again, which will make it easier for you to identify the important nucleotides.